Good morning, dear students. Today we'll talk about subcrane structures. So, as you know, the most often um, place of using substrain structures is the industrial buildings. So, it also call it like a crane beams with the rails. So the crane beams with the rails laid along the form the parts of the bridge cranes and firmly connected with the columns gives the frame additional special rigidity. So, reinforced concrete crane girders are recommended for use on the bridge cranes with a lifting capacity up to 30 tons of medium or uh, light duty with a column step, so column pitch of 6 to 12 meters. So, reinforced concrete crane girders have T and I sections. So, like steel crane girders also have the same sections like T or I sections. So, with the thickening of walls on the support. So, the dimensions of the beams are taken depending on the span between the columns, so pitch between the columns, and lifting capacity of the cranes. Um, so, substrate structures. So, with a column pitch of 6 meters, beams have a length about 500, 5,950 millimeters. So, and the section of height about 800, 1000 and 1200 millimeters. So a shelf width will be 550, 600 and 700 millimeters. So with the column pitch, so with the column step between two columns 12 meters, the length of the beam, um, subcrane, actually subcrane beam will be about 11,950 millimeters. The height of 1,400, 1,600 and 2,000 millimeters. So, and the shelf width of 650 and 750 millimeters. So the wide beam flange provide reinforcement of the compressed zone and for lateral horizontal crane loads, and also simplifies as fastening of crane rails. So crane beams are made of various type of concrete marks and the steel marks. So the beam are provided with embedded elements for fastening to the columns, so steel sheets, and for attaching the crane rails to the tubes of diameter about 20 to 25 millimeters. So installed every 750 millimeters along the length of the shell. So the crane beams are fixed to the columns by using the welding or embedded elements and anchor bolts. So the bolted joints are welded after the final alignment of the beams, of the crane beams. So the types of crane structures. So the main load-bearing elements of the crane structures, the crane beams, can have various structural shapes. So the most common used, the most the most commonly used types of structural shapes is the crane beams, boss split, so continuous crane beams, boss slip, and just the continuous beams. So uh, a split, single span split beam are earliest to install. So insensitive to the draft at the support. So however, they have an increased steel consumption. Continuous beams, um, which showed on the figure B, are 12 to 50% more economical. So in terms of metal consumption, so but more laborious during the installation. So due to arrangement of mounting joints. So in addition, during the settlement of supports, additional strengths arise in them. The third is with the light cranes. So the crane guide used with the light cranes when the capacity Q will be more or equal to 30 tons and the large column large column step. So lattice crane guiders with the rigid upper chord is advisable. So there are use a possible so actually possible to reduce the steel consumption by the 15 to 20 percent. So in comparison with the split solid beams. Um, the advantages of the lattice beams is in increased labor intensity of manufacturing and installation and low durability with the cranes for the special operation. Next one for large span. So when the column spacing 24 or more step and heavy duty cranes. So crane rafted trusses are used. So combined a crane guider and rafted truss, the efficiency of the truss structures increases with the increase in column spacing and is for to 6% in column spacing of 24 meters and 12 to 60 at step of 36 meters. So, however, such trusses are quite difficult to manufacture and install them. And the last one is suspended cranes, so guider cranes. have as a rule a low lifting capacity, approximately about up to 5 tons, and move along the tracks attached to the roof or floor structures. So for the repair of equipment, for auxiliary operations, building are equipped with the auxiliary hoists, so showed on the figure A. So moving along monorail tracks made of rolling I-beams. So there are two figure B and the three showed on the figure C. A multi-support cranes can be used. So the main types of tracks are rolling from I-beams, composite beams, so installed in a split or continuous patterns. So with a track span of 12 meters, perforated beams can be used, showed in the figure number 3, um, to reduce the bending moments. Additional suspensions can be installed in that beams. So here is we see the difference in height between the beams at the joints. So it's allowed no more than 2 millimeters. So the rails are attached to the crane guiders with the steel paired legs from two parts. Uh, so paired legs, so the attached paired legs located to the crane guiders, spaced about 750 millimeters apart. So in the order to reduce noise during the crane movement, um, to reduce the dynamic effect on the beams, and increase the durability of the crane tracks. Uh, Elastic gaskets made of the uh, rubberized fabric with a thickness of 8 to 10 millimeters are placed under the rail and legs. So the crane structure for bridge support the crane, um, which consist of the crane guiders or trusses that receive the vertical crane loads D on the picture at the left. Brake structures that perceive transverse horizontal effect T, um, showed on the picture. Um, Connections that ensure the rigidity and uh, immutability of the crane structure. Nodes transmitting crane effects on the columns. Uh, the crane rails with the fasteners and the tops. Um, the main features of walk and loading mode. So the operation of the crane structures, so under the operating conditions, are very complex and differs significantly from the operation of the conventional guided structures. So this is due to specifics of loads, nature of its application, so the difference between the real and calculated design schemes. So, concentrated loads, concentrated vertical crane load, reaching large values, about 600 to 800 kilonewtons, is applied at any point along the length so of the beam and leads to the appearance of a complex strength state in the wall at the higher stress level. So due to eccentric application of the vertical load and horizontal forces applied at the level of the railhead, so additional acts on the upper third of the beam, so causing the web to bend. Um, Vertical and lateral impacts of the cranes are dynamic in nature and are often accompanied by the jerks and impacts. So this is facilitated by irregularities to the crane tracks and differences at the rail joint. So all this leads to the appearance of damage in the crane structure form, um, for fatigue cracks, breakdown of connections, um, losing the units and disrupt normal operation uh, through the time. So calculation, calculated values of the vertical and the horizontal forces um, determined by the formulas. So here you can find two main formulas of the determining the vertical and the horizontal forces and the main factors. So since the fatigue failure occurs as result of the action, so of not the maximum but of a repetitive load. So when the calculating structures for endurance, the most frequently acting loads are taken, so which are determined by the multiplying the standard loads by reduction factor depending on the operating mode of the crane. Um, so rigidity of the crane beams is checked for the load from one crane with the load safety factors um, uh, sigma k, which are equal to 1, um, and the load safety factor sigma phi 1 point gamma phi, actually gamma phi 1.1 without taking into account the dynamic factor. So the brake beams used as platforms for maintenance and repair of the crane tracks designed for temporary load taken according to the technical specification. So the dead weight of crane structure is taken according to the reference date and approximate effect of own weight of the crane structure and the temporary load on the brake beams can be taken into account by multiplying the calculated forces from the vertical crane um, load by the coefficient uh, alpha and equal to for beams with the span of 6 meter 1.03, for 12 meters 1.05, and for 18 meters 1.08. So design solutions of the crane beams. With we can divide it for several various steps. The first is the crane beams with a span up to 6 meter and uh, small crane lifting capacity, so up to 10 tons. For beams can be used rolling I-beams. So for crane beams with a higher lifting capacity, approximately about up to 50 tons. So with the cranes operating mode 1K to 5K, so lightweight and heavy modes, rolling I-beams can be also used, but to perceive horizontal transfer loads, so they must be reinforced with sheet or corners or any asymmetric welded sections with a reinforced upper chert should be adopted. So for the latch spans and the lifting capacity of the cranes, welded I-beams with the horizontal braking structures are used. So for cranes with a lifting capacity about up to 50 tons, beams of composite cross section made of the wide flange uh, T-bars with thin walls and insert are rational. So to reduce the consumption of steel, welded beams are sometimes designed two grades of steel. So the wall is made of low carbon steel, and the belt is made of low alloy steel. So this method actually helps to reduce the consumption of the steel during the design of the crane beams. The higher intensity of operation of special mode cranes often leads to damage in the support zone. So of the wall of the crane guider. So such as beams, in order to reduce the level of local stress, the wall um, arising from eccentric application of the crane load. So it is um, advisable to increase the torsional rigidity of the upper chord by the placing vertical or inclined elements, um, or use two-stage sections. So two-stage sections is showed on the right part of the picture, and the by using inclined elements, lamellas is showed on the left part. So the solution of crane beams with the replaceable upper part, which I used in the or like some improvements for design solutions of the crane beams made of the uh, wide flange I-beams, so attached with the higher strength bolts, also distinguished by the increased durability. So riveted beams are heavier than welded beams and more laborious to manufacture them. But however, due to their higher durability, they are used in building of ferrous metallurgy plants with special duty cranes. So special duty cranes, it's a heavy mode. So, with the latch span of the beams for crane with the lifting capacity about 50 tons or more, the special brake structures, brake um, beams or trusses are installed. So the brake beams with the corrugated sheet walls about 6 to 8 mm, millimeters thick are used. So as well as brake beams made of bent sheet. So in order to prevent horizontal displacements of the beam from being transmitted to the wall of the building, so this fastening is performed using the uh, sheet hinge. So in the middle rows, the upper belts of the beams of the spans are belts of brake beam. Sheets of brake beams are welded to belts with a continuous seam with a weld on the bottom side or fastened with the higher strength bolts. So to ensure local stability and prevent any accidental deflections, the brake sheet are reinforced with below stiffnesses. Calculation of the crane beams. So calculation of crane beams is in many ways similar to the calculation of the conventional beams. However, the moving load which causes the large local stresses under crane rolls and the effect of not only vertical but also the horizontal loads, dynamic loads, the multiply of its application lead to the fact um, that calculation of the crane beams has some features. So consider the features of the calculation crane beams related to the specific of their work. So the design forces, greatest bending moments, transverse forces in the crane girders are found. So from the load of two closely spaced cranes of the highest lifting capacity, since the load is mobile, you first need to find its position, so at which the design forces in the beams will be greatest. And the greatest bending moment in a split beam from the given system of forces um, occur to when the result of the forces on the beam closer to it are equally distant from the middle of the spin uh, beam. So the greatest shear forces Q max is a split beam will be at the position of the load when one of the forces is located directly at the support, and the rest are located as close as possible to the same support. So when the calculating the beams is conveniently assumed that the vertical loads is perceived only by the section of the crane girder without taking into account the brake structures, and the horizontal load is taken only by the brake beam. So um, we can find the bending moments and shear moments according to the formulas showed on the screen. So, and the last slide for today, it is finding the maximum strength. So, the aperture of the beam works both in vertical and the horizontal loads, and actually it determined by the formulas. The sigma A equal to mx divide wx plus my divide wya, so it's less or equal to ry, and so here is you see the all coefficients which we need to add to find the needable maximum stress at the point, and there are relative upper belt to the vertical position and in extreme point of the upper belt. So we have about 2 minutes, and now I need to check who is absent and who is present today. Okay, if you have questions, actually, you can give it to me, and so I will answer it.